Hello, in this video I want to look at some examples of order of operations. So whenever you hear the order of operations, it usually means that you're talking about an expression that involves more than one operation symbol. So for instance, if we had something like 5 times 2 plus 3, then we would actually be using the order of operations. Now, you do have that there's a set of steps that you have to use in order to find what an expression simplifies to, which, one says that you have to work separately above and below each fraction bar. The next step says that you would have to use rules below within each set of parentheses or square brackets, and then you start with the innermost set and work outward. And then it says that, if there are no grouping symbols that are present, you follow the steps of powers and roots, and you work from left to right. And then multiplication and division are going to be from left to right. And then you have any negations, additions, or subtractions in order work from left to right. Okay, so that's a lot to kind of comprehend in any case. And most people will actually associate order of operations in the most simplest way that we can think of it, which is just think of it in terms of first you have, as the step said, that you work the parentheses, and then you follow with the exponents, and then you follow with the multiplication. Now, multiplication and division are about the same, so it's actually whichever comes first or from left to right. So you have multiplication, division, and then you have the addition and the subtraction, of which, most people will say, please excuse my dear Aunt Sally, in order to kind of memorize the order of operations. Or maybe you can just use this nice, funny picture of the addition symbol letting parentheses, exponents, and divisions go first. Of course, in that case, it's actually missing subtraction and multiplication, but in actuality, this picture does demonstrate the order of operations in some kind of way. But that's not how you want to, learn order of operations exactly. So let's just do an example. So say, for example, that we look at 6 divided by 3 plus 2 cubed multiplied by 5. Okay, so we want to evaluate this expression. And the way that we first will do this is that we notice that in looking at this expression that we have division, addition, exponents, and multiplication. Accordingly, we're going to evaluate the exponent first. So in that case, we would go ahead and say that this is going to be, we'll just say equals 6 divided by 3 plus, well, 2 cubed is actually just 8. So that's going to be 8 multiplied by 5. Now the next thing that we'll have to do is to divide. So we're going to actually divide now the 6 by 3. So that's going to give us that you have 2 plus 8 times 5. Okay, so this is actually very similar to, how I wrote 5 times 2 plus 3. But now we go ahead and we do the next operation, which the next operation would be multiplication. So we have 2 plus, well, 8 times 5 is 40. So we have 40. And now we go ahead and we just add. So this gives us 42. So the expression simplified to 42. Now, one thing that you would want to do is to avoid common errors. So, for instance, if you were to look at a common error, Some common errors involve, like for instance, if we have 32 minus 8 and we have that this is divided by 2, that you might accidentally say, well, 32 minus 8 is 24, so you have 24 divided by 12, and then you'll say, well, 24 divided by 12, that's, well, 24 divided by 2, sorry, is equal to 12, but that's actually not true. So you want to actually try to avoid common errors such as this right here, because order of operations say that you need to perform the division first, then go ahead and do the subtraction. Okay, so let's go ahead and look at another example, for instance. So another example where we use the order of operations could be such as, like, if I have 2 cubed minus 8 and we have divided by 4, but we also have multiplied by 2, and then we have plus 7. Okay, so I want to try to solve this, or try to simplify it, by using the order of operations. So this actually seems a little such as like the common error example right here, but let's go ahead and just work this out. So looking at this, I have the exponent of 2 cubed, which is actually just going to be 8 minus, okay, so we have 8 divided by 4, and then that's going to be multiplied by 2, and then you have plus 7. Okay, now accordingly we have to move from left to right, because looking at the operations according to our PEMDAS, oops, we have that the division actually comes first, so we have to do that first. So we have 8 minus, well, 8 divided by 4 is actually going to be 2, and that's multiplied by 2, and then that's plus 7. Now, the next thing to work out would be to do 2 times 2. So we have 8 minus 4 plus 7, and then from here we have 4, because now at this point we can actually just do the addition subtraction, but again we're moving from left to right. So we have 4 plus 7, which is equal to 11. So we have that that's going to be 11. Now let's say, for example, that we want to look at whenever there's a fraction. So according to the steps that were posted, we have that you have to evaluate each numerator and denominator individually. So like if you have -9 times -3, and then we'll do plus -5, and all of this is divided by 3 times -4 minus 5 times 2. Okay, so we're told that we need to use the order of operations, but use it respectively for the top and for the bottom. So it looks that what we can do is go ahead and work the top part. So we're going to work it separately, okay? So -9 times -3 is going to be positive 27. Okay, so we have plus -5. But we also have that from left to right, you have -12 minus 10. Okay, so from here we have that we can go ahead and combine. So this is going to be 27 minus 5. Okay, so we can break the parentheses and have 27 minus 5 divided by Okay, if you want to go ahead and simplify the part of negative 12 minus 10, you can, but I'll just go ahead and leave it. So this will be now where we have 22 divided by negative 22. Now, one thing that you'll notice is that there will be some cancellation. You have that 22 cancels out, and that simplifies to negative 1. So we have that that's going to be actually negative 1. Now, one thing that I can encourage is that you could practice using a calculator, for instance, but note that the calculator is going to require still the order of operations. So in that case, that means that for that example, you would have to contain the top part within its own set of parentheses. You would have to use this negative symbol, so you have negative 9 multiplied by, okay, so in this case, we had that was minus 3, and then we also have that that was going to be plus negative 5, and then we just close the parentheses. Okay, now we could have put a parenthesis around negative 3, but you don't really have to. And then we're going to go ahead and just put an open set of parentheses, and then 3 times negative 4. And then now the differences here is that I need to use a subtraction symbol. So minus 5 times 2, and then you just close it. And when you click enter, it gives us negative 1, which is exactly what we got over here, but we did it using order of operations and then applying PEMDAS for the top and for the bottom, and then simplifying last. Okay, so that's going to be it for order of operations.